Hello friend, Namaskar, I am JK. Dr. K Mohan sir has so far explained to us about raw materials, cement manufacturing process and cement composition. Now I would like to request Dr. K Mohan sir to tell about the clinker chemistry.
As you are aware, clinker is produced by heating kiln feed comprising of limestone, clay and corrective materials like laterite, bauxite, etc. for a temperature of 1400 to 1450 degrees centigrade. A series of chemical reactions take place from 100 degrees centigrade to 1450 degrees centigrade during the kiln feed burning in the rotary kiln, and clinker compounds or clinker minerals phases are formed. So now I will discuss the chemical composition of clinker. So clinker oxide chemical composition. So lime CO varies from 60 to 67%. Silica SiO2 varies from 17 to 25%. Alumina Al2O3 varies from 3 to 8%. Iron oxide Fe2O3 varies from 4 to 6%. Magnesia MgO varies from 1 to 5%. And then free lime or uncombined lime is there about 1 to 2%. In addition, alkalis like Na2O, K2O, and chloride and SO3 are also present in small amounts. Now I would like to talk about the phase composition or compound composition of clinker. The four main compounds of clinker are C3S, that is C3A is the shorthand notation, and full form will be 3CaO SiO2, that is tricalcium silicate. And industrial clinker we refer to as halite, and it is 45 to 60%. Second mineral is C2S, that is 2CaO SiO2 dicalcium silicate, or halite, that is 15 to 35%. Then you have C3A, 3CaO Al2O3, that is tricalcium aluminate. It is also referred to as aluminate and silite in industrial clinker, 5 to 12%. And then C4A, 4CaO Al2O3 Fe2O3, that is tetracalcium aluminum ferrite, or simply ferrite in industrial clinker, 10 to 14%. In addition, 1 to 2% free lime, 1 to 5% of periclase, that is MgO, small amounts of alkali sulfates, that is sodium sulfates and potassium sulfates, and alkali chlorides like sodium chloride and potassium chlorides are also present. Besides, clinker contains liquid phase or clinker melt in the range of 26 to 30%. Now I would like to discuss about the structures of clinker compounds. Now let us look at the structure of these different compounds and what causes them to have differences in their reactivity. C3S is probably the most important compound in modern cement because it is related to the early strength development that we desire in the cement. The irregular structure of the C3S crystal causes C3S to have a high reactivity. The high reactivity also implies a high heat of hydration. That means when C3S reacts, it liberates a lot of heat, and that is one of the problems in OPC. That OPC releases tremendous amount of heat upon hydration. Depending upon the impurities that are present in the system and the kind of heating processes that occur in the kiln, followed by the cooling process, you can actually get multiple polymorphs of the C3S. Polymorphs indicate different crystal forms of the same compound. For example, calcium carbonate is present as calcite or as aragonite. Both of them are calcium carbonate, but they have different crystal forms. So those are polymorphs of calcium carbonate. Similar to that, C3S has various polymorphs. Halite is the name given to impure C3S, which contains magnesium oxide, aluminum oxide, and iron oxide, along with smaller quantities, but very important quantities of the alkalis and sulfates. Primarily, the alkali sulfates are the ones which have attached themselves to the surface of the clinker particles, and these alkali sulfates are the ones which lead to a high degree of reactivity with the halite. 7 polymorphs of halite are known. 3 triclinic polymorph, T1, T2, T3, 3 monoclinic, M1, M2, M3, and a rhombohedral high temperature polymorph R. In industrial clinkers, the M1 and M3 polymorphs are mostly stabilized at room temperature by the presence of sulfate or magnesium impurities, respectively. M1 polymorph is more reactive than M3 polymorph. That we must understand. And it is a very important aspect to know that M1 polymorph is more reactive than M3 polymorph, and it has this has implication in industrial clinker. C3S, on the other hand, have a much more regular or rounded structure. The regular structure implies a lower reactivity. Again, similar to C3S, there are several polymorphs that may exist depending upon the kind of heating and cooling processes. C2S has polymorphs known as alpha, beta, and gamma. The low temperature form is gamma C2S. This form is non-hydraulic and does not hydrate and is avoided in cement manufacture. As the temperature rises, it passes through beta and then gamma polymorph. Beta is the high temperature form and is stabilized at low temperature because of the incorporation of impurities. Beta C2S of halite is hydraulic, and that is what we are commonly finding in modern cement. Gamma C2S is much less dense than beta C2S, and this causes the beta C2S to crack and fall to a more voluminous powder on cooling, a phenomenon known as dusting. Now, pure C3S has a cubic structure, and cubic is a very high ordered material, and a very high order implies obviously a controlled reactivity. But with the impurity oxide that are present with C3A, just like with C3S or C2S, you can have other forms of C3 also, like orthorhombic. When you have the other forms, there could be some distortion in your bonds that leads to high reactivity in the system. The C3A phase occurs as a series of solid solution in clinker. The structure of C3A is cubic at low potassium content and orthorhombic at moderate potassium.
Sir, I have one more question. Sir, can you please enlighten us about the importance of clinker liquid phase? Liquid phase का क्या importance होता है?
So you have asked me now to talk about importance of liquid phase. So I will discuss that in detail because this is a very important aspect. Clinker liquid phase or clinker melt is the fraction of the kiln feed that melts between the upper transition zone and the burning, that is between 900 to 1400 degrees centigrade. Plant chemists and kiln operators are usually more concerned with the amount of liquid present rather than the rheological properties, that is fluid properties such as viscosity. Although the latter is much more important during the clinkering reaction than the former. For most commercial clinker, the amount of liquid phase in the burning zone varies between 26 to 30%. Higher values can be damaging to most refractory bricks in the absence of a stable coating. The tendency towards coating formation increases with the amount of coating. However, more coating does not necessarily mean better coating. Coating refractoriness, texture, and stability are far more important than the amount of coating deposited on the line. The most important clinker mineral, C3S halite, requires the presence of liquid for its formation. In the absence of liquid, halite formation is extremely slow and would render commercial clinkering impossible. Liquid phase viscosity increase linearly with the alumina mortars, that is A by F ratio. For a given burning temperature, high C3A clinkers tend to nodalize better than low C3A clinkers. Another important property of the liquid phase is its surface tension or its ability to wet the lining. The surface tension has a direct impact on clinker fineness, coating adherence to the lining, and the clinker quality. High surface tension values favor noodle formation and liquid penetration through the noodles. The resulting clinker contains less dust, that is -1 mm fraction, and lower free line. Alkali, MgO, and SO3 reduce liquid surface tension, as does temperature. Sulfur and potassium have the strongest effect, followed by sodium and magnesium. Therefore, MgO, SO3, and K2O are good coating parameters.
आशा करते हैं दोस्तों आज आपको अच्छी खासी जानकारी हासिल हुई होगी। अगर हमारा वीडियो आपको पसंद आया हो लाइक और शेयर जरूर कीजिएगा। अगर हमारे यूट्यूब चैनल पर नए हैं सब्सक्राइब करना ना भूलें, बेल आइकन को जरूर हिट कीजिएगा, जिससे आपको लेटेस्ट अपडेट नोटिफिकेशन मिलता रहेगा, हमारा मोटिवेशन बढ़ता रहेगा। और दोस्त मैं एक चीज़ और आपको बताना चाह रहा हूँ कि आने वाले सीरीज़ में आपको सीमेंट से रिलेटेड जितनी भी जानकारी आनी है केमिस्ट्री से रिलेटेड, वो सारी 1 बाय 1 आती रहेंगी। आप बने रहिए और इंतज़ार करते रहिए, बने रहिए, नोट उसका बनाइए और सीमेंट केमिस्ट्री की पूरी जानकारी आपको इस चैनल के द्वारा प्राप्त हो जाएगा। वीडियो देखने के लिए बहुत बहुत धन्यवाद।